Hello students, welcome to my YouTube channel Concept Tech 2018. I am Dr. Sunanda Manke and this video is a part of series on online electronics laboratory, and in this part we'll discuss lab exercises on transistors. The assignments here includes the common base transistor, common emitter transistor, JFET and MOSFET characteristics. The first assignment is common base transistor. When BJT is used as common base circuit, as you can observe in the figure, the base is common and input is applied between emitter and base and output is observed between collector and base. So we'll apply input, DC input to the input side as well as output side because we are biasing it, input side forward biased, output side reverse biased. We'll observe the input current and voltage, and similarly we'll observe output current and voltage at the output side. We'll vary the DC voltage at the input side and we'll keep the output voltage constant, and then we'll observe the input current as well as the output current for different values of the input voltage. Common base circuit, the transistor is connected as per the circuit discussed earlier. These are the two supplies, input supply and output supply, which are connected to the transistor. And now we'll observe the behavior of the transistor here. This is the input voltage, input current, emitter current, collector current and collector voltage. So base to emitter voltage, emitter current and collector current. We'll observe closely the emitter current and the collector current. Both are in the milliampere range. And you can see here, when we increase the input supply, the emitter current and collector current are varying in exactly same manner. They are replica of each other because IC is alpha times IE, alpha is almost 1. So whatever is the emitter current, same is the collector current, that you can observe here. The input is at 0.6 volts as it can be observed on the voltmeter also. As the input is forward biased, when you go beyond this 0.6, there is a sharp rise in the input current and output current. The reverse voltage is at 2 volts. You can see the variation, same variation in collector current and emitter current. From this experiment, we have observed that the input side was forward biased and output side was reverse biased. That is, emitter base junction was forward biased using DC supply and collector base junction was reverse biased. As we increase the input supply, the input current increases and this results in increment in the output current by the same amount. And this is because IC is alpha times IE and value of alpha is 1. Emitter and collector currents are equal. We'll do the same experiment in virtual lab. So this is the web page for the lab, Electronics and Communication Engineering lab. Then the list of experiments are given. In this list, we'll click on BJT common base characteristics. We reach to this page where all the details are given. The theory part of the BJT common base characteristic is given. Then a test also is given. Then we can click on the procedure and check the procedure of the experiment. When we click on simulation, there are two options, input characteristics and output characteristics. We'll click on input first. In this, the instructions are given for doing the experiment. That is, we have to set both the resistances, variable resistances, which are given to 1 ohms. Then we have to set the VCB to 1 volts, and then by varying the RH1, we'll vary VBE and we'll observe the input current to get the input curve. So let us set RH1 to 1 ohms. Now we'll set RH2 so that the VCB value is 1 volts. Once VCB is 1 volt achieved, then we can check and add the current and input voltage value to the table. And you can see in this case the emitter current is 0. Now we'll increase the value of RH1 and thereby the emitter current will increase. Let us increase the value of RH1 and add the entry of the input voltage and input current to the table so that a graph can be plotted between input voltage and input current. So we'll go on increasing the value of RH1 and we'll add the entry in the table, and you can observe here that the base to collector voltage is set to 1 volt. So the curve will be drawn for VCB equal to 1 volt. Once we have reached to the maximum value of the RH1, we can plot the curve and then We can change the value of VCB and we can again observe the change in the current. You can observe here as soon the 0.6 volts is reached, there is a sharp increase in the current, right? Let us plot the curve. You can see there is a sharp rise in the current with change in the base to emitter voltage. Now we can increase the RH2 resistance value so that we can plot the curve for VCB equals to 2 volts. RH1 set, and now entry can be added to the table. We'll do the same again. We'll go on increasing the value of RH1. Thereby we are increasing the base to emitter voltage and we are observing the base to emitter current, that is IE we are observing for different values of VB, right? This is common base configuration. So base is common, input side is emitter side and output side is the collector side. The curve shows increase in current with increase in voltage. Let's go to output characteristic curves. In this curve again we can go through the instructions. Now for drawing the output curve, we have to set emitter current to a constant value and then we have to observe the collector current and collector to base voltage. So with the help of RH2, we will change the reverse bias at the output. First of all, RH1 is set so that we get 1 milliamps current at the emitter side, and then we will change RH2 and observe the reading. RH2 basically is changing the reverse bias applied at the output side, and you can observe change in RH2 does not result in any change in the collector current because collector current is equal to emitter current. So you can see here increasing VCB does not increase IC because we are in the active region. Forward bias applied to input side and reverse bias applied to output side, right? So you can see PNP transistor is there and the curve change in VCB does not change the collector current. For initial values it changes. Once the reverse bias is established, there is no change in the collector current, it is constant. Let us change the value of the emitter current to 2 milliamps. Now by changing RH2, we can add the entry to the table and you can observe for initial values of the VCB, collector current is varying, but as soon we go above 0.7 volts, above the base to emitter junction voltage, the transistor goes into active region and collector current becomes constant and equal to emitter current. Plotting of the curve shows collector current is constant and equal to emitter current. I hope you have understood how common base circuit works. Thank you.